And from US, now we're going to move to Austria. And I can see that Gisela, Ofenböck, you are here from the Federal Ministry of Agriculture, Forestry, Regions and Water Management. And you also have, are you alone or you have your colleague? You're two. Yeah. Franz Greimel, yes. University of Natural Resources and Life Science, Department of Water, Atmosphere and Environment. So you're both welcome to provide your note.
Yes. Thank you very much for the invitation to this conference and for the opportunity to present the Austrian approach for sustainable hydropower. I will give a short overview about the general conditions in Austria, and then I will hand over to my colleague Franz Greimel from the University of Life Science, BOKU in Vienna, to present one example. So, yeah, looking on the situation in Austria, as in the Scandinavian countries, also Austria is a hydropower country. It is hydropower is of high importance for the Austrian electricity supply. About 2/3 of the total Austrian electricity production comes from hydropower. And we have many, many hydropower plants, around 5,000 all over Austria. Around 3,000 are feeding into the power grid, and 2,000 very small micro plants are only for self-supply. Those that feed into the power grid have a total capacity of 14.6 gigawatt, and they are mainly run off river plants. But there are also 114 storage plants, which are very important for the Austrian system, also for the European grid system, because they can provide flexible energy, regulatory energy. But the majority of our hydropower plants are small hydropower plants. 95% of all the hydropower plants are below 10 megawatt. And they represent only 10% of the installed capacity. And as you can see here, so these 90% of the hydropower plants produce 10% of the energy, and the other way around. So 10% of the hydropower plants around have 90% of the electricity production. Coming to the ecological side. Oh. What happened here?
Probably we need some help.
Yeah, but it jumped almost half of the presentation. Does it work for you jumping back? Or? No, I think you have to go out. It's too many. Yeah. Yeah. It's just yeah. Yeah. Coming to the ecological status of our rivers, here you can see that still 57% of our water bodies fail the target of good ecological status. So there are a lot of measures to be set to reach this good ecological status as asked for in the WFD. And there are also 2/3 of the Austrian fish species are endangered. And this is not only caused by hydropower. Of course, there are several more pressures to our rivers, but to a major part it's caused by hydropower, as you have seen on the map of these many little and big hydropower plants. So what are the main pressures? Continuity interruption. In total, we have now around 27,000 continuity interruption in a river network of 32,000 kilometers, so almost 1 per kilometer. The major cause of this is flood protection, but around 11% of these continuity interruptions come from hydropower plants. And the more you go to the larger rivers, so from the Danube and the Danube tributaries, the majority of the continuity interruption is caused by hydropower. The more you go upstream, it's caused by flood protection. There are also impoundments, of course, water abstractions. Also here, the majority is caused by hydropower use. Hydropeaking, 100%. and also hydromorphological alteration. For example, in the impoundments, there is also an alteration of the habitats. This is also caused by a certain part by hydropower. So it is clear that a lot of measures have to be set by the hydropower sector. And we have different goals that have to be met. We've seen it already in the morning session. We have to increase the renewable energies to mitigate climate change and overcome the energy crisis. We have to protect and we have to guarantee a sustainable use of our waters, and we have to protect endangered species and habitats. And to increase the biodiversity, and the main goal to restore our ecosystem. So there are different aspects, different crises that we have to manage now. And this, of course, is a very challenging task to do, to balance these conflicting interests. When we talk about sustainability, it's balance between economy, society, and environments, and coming to the sustainable hydropower use. We think that there are two main aspects that we have to look at. It is, on the one hand, the restoration and mitigation of the impacts that hydropower has on our rivers, and it is also about managing hydropower development. And both of these have to be in compliance with green standards, which are already in our legal requirements. So this applies both to existing and new hydropower plants. So the Austrian strategy for this consists of 4 main factors. On the one hand, we have included in our law green standards to minimize the impact on aquatic ecology. These are mandatory mitigation measures for new and for existing hydropower plants. For new hydropower plants, they apply directly. For the existing ones, we lay down the roadmap to reach this goal in our river basin management plan with a stepwise approach. The second factor for sustainable hydropower is to find out win-win solutions and to boost some hidden potential, because there are many possibilities to upgrade existing hydropower plants by refurbishment, optimization, modernization of these hydropower plants, and at the same time improve also the ecology of our rivers. So this upgrading is very important now, and we can see now that there is a big potential in getting even more hydropower production by optimizing these old power plants. The third factor is the strategic planning for the appropriate site selection. So not every site is really appropriate for a new hydropower plant. And in this strategic planning, it is a major part to balance these conflicting interests and also a way to make use of some synergies that can be found between these aspects. The fourth factor is research and innovation. We have to increase the knowledge about the effects of hydropower, about the possible measures to find really tailor-made solutions for reaching the goals, and at the same time minimize the impacts also on the hydropower use, because as you have seen, the hydropower production is very important in Austria. So we should find those solutions that minimize the impacts both on ecology and on the hydropower production. What are these green standards that I was talking about? They are included in the Austrian law and are mandatory for new and existing hydropower plants. This is ecological continuity. So, for example, building fish baths, this is required for all hydropower plants, and it is required also for all other continuity interruptions. So there are possibilities to, build fish baths, but also building ramps for flood protection weirs and so on. There are many different measures that can be set, but continuity is state of the art for the Austrian rivers. The second part is the ecological flow. This includes quantity and dynamics of flows. Also, our law includes standards for setting this ecological minimum flow. This has to be guaranteed by all kinds, not only by hydropower, but all kinds of facilities that abstract water from our rivers. One general requirement that's also laid down in the Austrian law is that all the projects have to try to minimize the negative effects on ecology. This applies really to all kinds of pressures. Example would be impoundments, where you're changing the character, but at the same time you are trying to improve some habitats or try to do the best you can do to avoid the impact on ecology. Concerning hydropeaking, there are also some guideline values included in our law, but for really setting the state of the art for measures, there is still research going on in Austria, and this will be the part of my colleague then to present you some of the results of this research. Coming to the strategic planning for new hydropower plants, which I think is really important nowadays, because there is by the emergency law and also by the Repower EU, there will be an additional hydropower plants built throughout Europe. In Austria, the potential for hydropower is already exploited up to 80%, so there's not so much left. And for these remaining regions, we really have to see where it's possible to build new hydropower plants and where the ecology is so sensitive that it's not really a good idea to do so. So we developed already some years ago a criteria catalog, which is a supporting tool for balancing these conflicting interests. It helps in this decision. It includes criteria for ecology, energy, and other water management criteria, like, for example, groundwater, drinking water, which also has to be taken into account in the process for a permit. Based on this criteria, we have some strategic planning for appropriate site selection on regional level. So our federal countries worked out those regions where hydropower can be built or which are very sensitive related to the ecology, which should be protected areas. On this regional level, you can also take into account this cumulative effect. So you have to see what is the summary effect of hydropower, new hydropower plants with other pressures that are already in the river. This has to be done on a catchment area. You can try to find the synergies and also have to look for other renewable options like solar and wind. This strategic planning should help that our decisions for new hydropower plants can be transparent, uniform, and reproducible. So we want to avoid situations where in one of our federal countries it's allowed to build something and in the neighboring country it's not. Also, it would be the same project. So it should be the same throughout Austria. Yeah, and now how to resolve these conflicting goals and interests. We already have a longer experience in the discussions with the hydropower sector. And I think from the beginning of the implementation of the Water Framework Directive, we really involved the sector very early in all the discussions. But at the beginning, it was more an exchange of positions. So just like, how important is hydropower, how bad is the situation, and so on. So it was not really coming to a good solution. So what is really needed here are integrative approaches and close cooperations between all the stakeholders that are involved in these processes. This is administration, it's the hydropower sector, and it's the science. And the goal is to find the best solutions, joint solutions for a very complex problem. So by doing, for example, joint research projects, we develop strategies which can be shared by all and can be implemented quickly. So in this research project, we wanted to develop basis for further decisions. We want to have fact-based decisions instead of just different positions from each side. It also helped in this research project that we can get some mutual understanding of the concerns and difficulties, so the hydropower sector understands why it is so important to improve ecology, and from the other side, the ecologists now also understand how difficult, for example, the whole management of the power grid and the whole situation in managing this and how important the hydropower can be achieved by this research project. So in the end, we want to get acceptance for joint decisions, for measures that can really be accepted by both sides. And now coming to the example that I promised, it's on hydro peaking, which is affecting around 700 to 800 kilometers of our rivers, which fail good ecological status. This flexible production of energy is so important that these water bodies that are affected are designated as heavily modified water bodies. And for these water bodies, we had joint research projects looking on the effects of ecology, on the measures, and also on the effects on the energy production, and developed a methodology for assessing good ecological potential. And in the River Basin Management Plan that was published last year, we included now an obligation for the hydropower companies to prepare feasibility studies for all rivers that are affected by hydropeaking, using this method that was developed by these joint research projects. And this is the moment where I will hand over to my colleague. He will go into the details of the projects.
Thank you. I don't need that. Can you hear me? Thank you very much. There's not too much time left, so I will hurry up to show you the example of at the end, it ended in an Austrian hydropeaking guideline. And I'm happy to show you this guideline, if that works. Yes. So just to the situation in Austria, like Gisela said, we have around 800 kilometers of affected river stretch. But I don't give it a chance anymore. Probably I have to click. Yes. Most water bodies are designated as heavily modified water bodies. As Wouter told us before lunch, there's a different goal according to the Water Framework Directive, which is the good ecological potential. We have around 80 potential hydropeaking sources, and all in all, there are strong differences in the hydrological situation. Sometimes we have small rivers with big power plants. Then we have big rivers with small hydropower plants. The hydropower plant schemes have different production schemes. So at the end, it's important to standardize all these methods, because if we discuss all these basics at every case, I think the goals to be met, probably 2100 or I don't know. It is a lot of years to go. Like Gisela already said, the installed capacity in Austria is around 25 gigawatt and storage and pump storage hydropower plants represent 1/3 of the Austrian hydropower plant capacity. And of course, we need this flexible energy production. And here we have this argument, we need these power plants to manage the energy and climate crisis. On the other hand, we have very wide poor ecological status, like also Gisela stated. For example, 2/3 of the Austrian fish species are endangered. The grayling is vulnerable, the Danube salmon is endangered, and also macroinvertebrates are widely affected by hydropeaking. And here's the argument, what's with the biodiversity crisis? We also have to look at this. And at the end, we have a huge conflict. Unfortunately, we have in Austria the Water Framework Directive dealing with such problems. And so, like Wouter said, we have to assess the impact on use and the ecological benefits on the other hand for all technical feasible measures in order to define the good ecological potential. So now I want to just go briefly through this Austrian hydropeaking guideline, which is of course in line with the European Water Framework Directive. And on the other hand, it should be based on a broad scientific basis. For that, we did in the last decades a lot of hydropeaking research at the Boca University, and of course, we read a lot of literature. The first issue I would go through is of course, we have to address the hydrology. On the one hand, we use this Eulerian perspective where we look at every flow fluctuations recorded in hydrographs. This is for sure the more important perspective for fishes, because the fishes or the benthic invertebrates don't distinguish between floods, natural floods, or flowways from this or that power plant. So this is important for, at the end, for pre and post monitoring, and also for hydrological monitoring for the actual state. Back again. And on the other hand, we have this Lagrangian perspective where we trace hydropeaking flow waves from specific power plants over multiple hydrographs, and that's important for a large-scale assessment of power plant-specific assessment of the stranding risk, for drift risk, and the habitat degradation risk. And that's important because in the Framework Directive, we have this polluter-based principle, so we have to look where are the pressures coming from. Then I want to address the morphology. That's dealing with ecohydraulic modeling. I won't say too much, but at the end, it's dealing with, this issue is dealing with a case-based conceptualization and design of indirect or morphological mitigation measures, and my colleague Christoph Hauer will give a talk about that. Then we also address the energy economics in a standardized way, of course. There we assess the impact on use and also the costs of every measure, which can be, which is technically impossible at the specific place there. And that's important to have these numbers to describe this impact on use. And of course, we have to look at the ecology part. There, on the one hand, we have standardized sampling designs for benthic invertebrates and also fish ecological sampling designs, and that's important for a standardized monitoring of the actual state as well as on the effects of mitigation measures. And then on the other hand, we use the existing data and we did a lot of experiments at our high-tech facilities, and that is the basis for impact assessment. And also, we will hear a lot of talks from my colleagues of Austria in the next sessions about that. And at the end, we put together all this information in order to do a standardized feasibility studies, where we contrast, on the one hand, the ecological benefits of every measure, which have to be more than minor. Then this measure can be designated as relevant measure to reach the good ecological potential. And on the other hand, we have to assess this impact on use. And that's the basis for the decision making for the good ecological potential. And dealing with the impact on use, with the flexible energy production, my colleague Martin Schletterer will give a talk the day after tomorrow. And at the end, so this ÖkoResh project was this research project, the last one. Like Gisela said, we had multiple research projects. And of course, the water authorities, the ministry was involved in this project, as well as the whole the whole hydropower production sector of Austria, which is very important because if you have all these stakeholders on the table, then all these findings are widely accepted, I would say. And then we had an unindependent energy market expert in the team and 2 institutes of the Boku University. Just to zoom out a little bit, I want to highlight that these research projects are really communication platforms. A lot of time goes into this information and discussion process where water authorities, NGOs, science, hydropower operators, and also consultants are brought together to discuss this issue, to give the information to all of these stakeholders. And of course, the goal is to do this stepwise measure implementation, which is going on now for multiple hydropower plant outlets. And at the end, through this, according to this standardized process, we want to close the gap and we want to learn from the data we get of the measure implementations out there. And so I'm coming to the end. Thank you very much for your attention.